Hi guys, it's Mrs. Seitz. Today what we're going to be looking at is we are going to be looking at lines and planes and angles. So before we get into that, just a couple of vocabulary words for us to review. So the first of which is parallel lines, and you need to write down this definition on your note taker. So parallel lines are two lines that are coplanar and do not intersect. So for example, and you can draw this picture up here too, pause the video if you need to. So in blue here, I've drawn a plane, and then I have two parallel lines. Now, I know that they're parallel because I have marked them with this little red mark here in between there. So the two lines are coplanar because they're on the same plane and they're not intersecting one another, so therefore it makes them parallel. Now, for two lines to be considered to be skew, which we've talked about that before, skew lines are two lines that are not coplanar, so not in the same plane, and they do not intersect. So if we take a look at this picture over here that's already drawn for you on your note taker, if you take a look at the line here that's at the bottom of the shape and the line that's at the top of the shape, you can see that they're clearly on two different planes and they are not intersecting. So therefore they are skew lines. So again, you want to write down this definition: two lines that are not coplanar and do not intersect. The other vocabulary word for us to review right now are parallel planes. Parallel planes are two planes that do not intersect. So a picture of this right now would be the picture that you see here with the blue plane and the green plane. You can see that they clearly are not intersecting with one another. So I wanted to show those pictures to you because whenever we do these type of problems in the future, sometimes pictures can get a little bit confusing. So let's just focus on this picture right here that has a plane and has line A, line B, and line C. So it kind of looks like right now that this line A, it kind of looks like it's doing a couple of different things. So take a moment right now and look at it. It almost looks like from the picture that the red line is almost intersecting line A. Line A, the red line, looks like it's intersecting line B and line C, but it's really not what's happening. The person that drew this picture was intending, I think, for that line to be intersecting the plane. So, a couple of things just to make sure that you're always aware of. You have to make sure whenever you're making assumptions about lines being parallel or lines being intersection and whatnot, you have to read what's given to you. The other thing is, if you want to make sure that lines are parallel or whatnot, you have to make sure that there's something indicating on them. So again, if you take a look, if there are little arrows that are drawn on them, then we could say something like line B and line C are parallel. Okay, so you have to have the arrowheads for a line statement to be said like that. So you might want to write that down. So you can only assume that lines are parallel if there are arrows drawn on sets of parallel lines. So for example, line B and line C would be parallel. So in fact, when you look at this picture, line A and line B are actually skew with one another, even though it looks like they're intersecting. Same thing with line A and line C. So you have to be really, really careful with the pictures. So over here, this picture of the two planes were actually intended to be drawn as parallel planes, but it looks like in the picture that they're intersecting, right? So you have to be it's so difficult sometimes because we have things that are given to us in 2D environments. You have to always look at the given information before you can start making assumptions based on the pictures. So I wanted to point those things out to you before we moved on. So now what we're going to do is we're going to apply some of those definitions and kind of the idea that I just told you to be careful about with the 2D drawings to help us to answer some questions. So It says, think of each segment in the diagram as part of a line. Which of the lines appear to fit the description? So parallel to line AB and contains D. So let's take a look at that. So parallel to line AB, which is the line that's right here. Okay, so I'm going to take a look at that. I'm just going to highlight that so I know. So parallel to this line. Okay, and it has to contain D. So parallel means it has to be in the same plane, but it can't be touching, it can't be intersecting. So when I look at the same plane, it has to be over in this direction, right? So when I do that, it looks to me like I'd probably be looking over here. It probably looks like segment, or I'm sorry, line CD. So I'm going to type that over here for my answer. So I'm going to write down CD. And then remember, you want to put that line above it. So line CD. Okay, now we have, has to be perpendicular to line AB. So again, I have that line highlighted and contains point D. So perpendicular means it's going to, could intersect, right? And it would be intersecting at a 90-degree angle, and it has to contain D. So let's take a look. So perpendicular. So it has to contain D. So if I take a look, maybe even, let's investigate maybe this part right here. If I'm looking at line AD, I would be perpendicular right here, coming down at a 90-degree angle across from this way from line AB, and I would also be containing the point D. So that's my answer for the second part. So my answer for part B would be line, line AD. All right, next one says skew to line AB. So skew means, let's go back up top to the top, two lines that are not coplanar and they do not intersect. Okay, so we can't be in the same plane and we can't intersect with AB, and it has to contain the point D. So if I take a look here, I'd be looking at maybe something over here in this direction, right? So maybe something on the face of maybe this cube of maybe D, G, and H. So I have to contain D. So I'm thinking maybe here, look at DH, okay? It would not be on the same plane, right? It would not intersect, but it would contain the point D. So I'm going to write that as my answer, DH. And make sure you put the line symbol above that. All right, and then it says for part D, name the plane that contain, or planes that contain D and appear to be parallel to plane ABE. So has to contain D and it has to be parallel to ABE. So let's see. I'm going to actually color on some things so we can see. All right, so ABE is this plane over here. So think of it as just like this side of our cube. Okay, so it has to be parallel to that plane, but it also has to contain point D. So when I take a look at that, I'm thinking it's got to be this section over here. Okay, so remember when we name a plane, when you name a plane, you have to have 3 letters. Okay, so there's a couple different ways that we can name this for our answer for part D. All right, there has to be this plane over here because it's not going to ever touch this plane over on the left-hand side. So again, I'm talking about, and I'll color it so you guys can see, I'm talking about this plane over here on the right-hand side. Okay, so how do we want to name this? Well, I can name this plane C, D, H as one possibility because you just need 3 letters. You could also name it plane G, C, D, okay? So just to give you two possible examples, okay? Just pick one of them, but you have to have 3 points for it to be considered a plane. All right, now we're going to move on and we're going to talk about some postulates that you guys are going to be adding to your collection of assumptions that we can build off of. So, one of those postulates is called the parallel postulate. It says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So when I take a look at this picture, if you take a look at point P, okay, so if there's a line and a point not on the line, so the red line and point P, then there is exactly one line through the point given through the point parallel to that. So then that means that you have that one exact line. So there's exactly one line through point P that is parallel to line L, okay? So you have the given line, you have the point, you have that one line that is exactly parallel. Okay, now likely there's a perpendicular postulate. So there is one line and a point not on the line. So we have line L and we have point P. Then there's exactly one line, so our red line that exists that is exactly perpendicular to the given line. One more definition before we move on to some more vocabulary that we're going to be adding is the word transversal. Typically, when we talk about two lines in a given diagram, we talk about a line that cuts through the two lines. So, for example, when I take a look at line B and line H, there's a whole bunch of angles, so angles 1 through 8, that are associated with lines B and H. But I can see that there's this line G that kind of cuts through all of them. What we call that line is called a transversal. It's called a line that intersects two or more coplanar lines at different points. So take some time to write that down. A transversal is a line that intersects two or more coplanar lines at different points. So again, in this diagram, this would be our transversal, line G. Okay, so now there's actually some special relationships that can be used to be built off of that. So if you take a look, two angles that are corresponding angles as if they occupy corresponding positions. So for example, angles 1 and 5 are corresponding angles. And here's the way I like to look at this. So think of it as a top half and a bottom half, okay? And in fact, I'm going to scroll down so you guys can only see, and I'm going to blow this up, angles 1, 2, 3, and 4 down here at the bottom. So see how angle 1 is in the top left, angle 2 is in the top right, angle 3 is in the bottom left, and angle 4 is in the bottom right. If I scroll down, and I'm going to blow this up some more, and let me scroll down up a little bit, angle 5 is in the top left, angle 6 is in the top right, angle 7 is in the bottom left, and angle 8 is in the bottom right. Two angles are considered corresponding angles if they are in corresponding positions, meaning like angle 1 and angle 5, they're both considered to be in the top left, okay? Let's actually circle another pair. Angle 2 and angle 6 would be another pair of corresponding angles because they're both considered to be in the top right. Another pair would be angle 3 and angle 7 because those both are in the bottom left. And then the last pair would be angle 4 and angle 8 because those would be both considered in the bottom right positions. Okay, another special relationship that we can see out of whenever you have maybe two sets of angles would be these different types of angles called, oops, sorry, I jumped around, called alternate exterior angles, okay? And I'm looking right over here. And it's exactly what the name says, okay? So consider these two lines almost like a positioning. And I'm going to write this for you guys. Consider this the inside or the interior of the two lines. You might want to write that. That means if you're on the outside of these two lines, you are in the exterior. Just like you'd be on the outside here. Okay, so that's the word exterior. The word alternate means on opposite sides. So again, we have this transversal that's cutting through, right? If we have angles that are on opposite sides of the transversal or alternate sides, they are called alternate exterior angles. So for example, angle 1 and angle 8 are on opposite sides of the transversal on the exterior or outside portion. Another pair would be angle 2 and angle 7 because they are on the exterior portion on opposite sides of the transversal. So let's keep going with our definitions. Okay, I see the word alternate popping up again. So alternate means on opposite sides. Interior means on the inside portion. So I'm going to write that down again. So interior is on the inside. Exterior is on the outside. And exterior is on the outside here. Okay, so two angles are alternate interior angles if they lie between two lines on opposite sides of the transversal. So I'm in the inside, so I'm focusing on angles 3, 4, 5, and 6. Okay, they're on the interior or alternate interior if we're on opposite sides. Okay, so right now I'm looking at 3 and 6 because they are on opposite sides of the transversal. Just like 4 and 5, they're in the interior but on opposite sides. So again, the words in the definition tell you placement. Okay, one of the last sets of definitions, two angles are consecutive interior angles if they lie between the two lines that are on the same side of the transversal. So sometimes when you hear the word consecutive interior, you might hear it referred to as same side interior. So you might want to write that next to it. It's also called same side interior. Okay, so we're in the interior again, so I'm focusing on angles 3, 4, 5, and 6. Consecutive means same side. So, for example, I'm looking at angle 3 and angle 5 because they're on the same side as the transversal. Another set would be angle 4 and angle 6 because they are also on the same side of the interior. Now, sometimes there are special relationships that are given to you with these types of definitions, okay? Right now, we don't know what those are, but all we need to do is start getting comfortable with exterior, interior, alternate, and same side, okay? So before we do that, I want us to actually go to the last page of our note taker, and we're actually going to start coloring some things in. As I tried to make this as easy as possible for you guys. So there's a lot of vocabulary, but I want to make sure that you guys have this under control. So one of those vocabulary words were corresponding angles. So I want you guys to pick out a color. Let's see, you can even maybe use this one. Let's see if that'll work. Okay, so the gray sort of angle here would be corresponding. So pick a color. And we're going to say that these, remember, corresponding means the same position, right? So this angle here is in the top left, and this angle here is also in the top left. Okay, so both top left. So these are corresponding. And this doesn't have to be perfect because you can see what my picture looks like, right? Okay, so then another thing I want you guys to do is I'd like you guys to type in the word, and let's make this a little bit bigger. Okay, so this is going to be the interior, right? Okay, and then I have to make the exterior, right? So this is the interior. Let's see if it'll let me move it. Yep. Okay, I'm just going to try again. All right, so I'm going to make this my exterior. I want you guys to type that as well, because we are on the outside of those two lines. Okay, so type the words interior and exterior. Okay, the next things that we're going to be coloring in would be alternate exterior. Okay, and you see that these are kind of indicated by the ones that are the stars. So we are alternate exterior is if we were on opposite sides of the transversal. So remember, the line that cuts everything in the middle is our transversal. So the one that cuts the two lines is our transversal, but we have to be on opposite sides of it and be on the outside. So we have to be in the exterior portion of it. So I have one pink angle and another pink angle down here because we're on opposite sides and we are in the exterior. So it's just to give you an example. These are alternate exteriors. Okay. Now I'm going to skip over vertical for right now because we've used that definition in the past. Okay. But let's stick to the ones that are the current ones. All right. Now, same side interior, another name for that, remember, is consecutive interior. So same side interior or consecutive interior means I'm looking in the inside, but it has to be on the same side of the transversal. So these are our polka dot ones. So I'm going to maybe pick green this time and I'm going to color them in. So again, they're on the interior portion of the space that's created by those two lines, and they're on the same side or the consecutive side of the transversal. Okay, another new definition would be alternate interior. Okay, so again, I'm on the interior again, but then I want to make sure that I am on opposite or alternating sides. I'm going to color this portion in red. And again, if you're doing your notes with, markers or colored pencils, yours is going to look a lot better, but it's just for, us to see visually what's going on. Okay, now the other relationship that wasn't mentioned, but I just still want you guys to know that it exists, is there could be something that's considered same side exterior. Okay, same side exterior means exactly what the name is. You're on the exterior portion of the two lines, but it's on the same side as the transversal. So right here where I'm coloring in yellow, and again on the exterior here, so exterior portion, same side of the transversal, and you can see again the transversal is indicated to you. And then the last thing I want you guys to do is just to color in our vertical angles because that's a definition from our past. So remember, the vertical angles are angles that are in that X, right? They're opposite from one another, and they're indicated to you guys through the stripes. And we know that those are equal. In the future, we're going to learn that there are special relationships formed by corresponding angles, alternate exterior, and whatnot, but I just wanted to show you guys for placement where everything is. All right, let's go back to our notes, and we're going to now start identifying the relationships that we see through the angles. Okay, so right now, guys, let's take a look at example 2. It says to list all pairs of angles that fit the description. Okay, so let's take a look at part A. Part A says we want to list all the angle pairs that are corresponding. Okay, so I'm going to type this one. Okay, let me make my font a little bit smaller. Okay, so for part A, I want corresponding, which means same spot. Okay, so angle 1 pairs up with angle 5. Because if I take a look at the drawing, those are both, if I tilt my head, those are both in the upper left-hand portion. Another pair would be angle 2 pairs up with angle 6 because those are both in the upper right-hand position. Another pair would be angle 3 and angle 7. And then finally, angle 4 and angle 8. Because again, those are all in the corresponding positions with one another. Okay, next, we want to go with alternate exterior. So alternate exterior would mean that we're looking at angles that are on the exterior of the two lines, right? But on opposite sides of the transversal. So remember, this right here is our transversal. Okay, and again, this is the exterior, and this is the exterior. So when I'm taking a look at my angle relationships, I want to be on opposite sides of this. So I would go angle 1 and angle 8. So I'm going to type that in. Another pair that I see would be angle 2 and angle 7. Okay, now for part C. For part C, I want alternate interior. So I want to go in this middle portion here that I'm looking at angles 3, 4, 5, and 6. I want to be on opposite sides. So that means I would be looking at, and I'm going to erase these so I don't get confused. I would be looking at angles 3 and 6 because they are on opposite sides in the interior. So angle 3 and angle 6. Another pair would be angle 4 and angle 5. Okay, and then finally for part D, I want consecutive interior, which means same side interior. So again, I'm looking on the inside portion there. So I'm going to erase this 3 and the 6, but I'm still looking at these 3, 4, 5, and 6 angles. I want to look on the same side of the transversal, so I'm looking at maybe perhaps angles 3 and 5. And another pair would be angle 4 and angle 6. To see if you guys have this under control, I want you to see if you can answer this portion of your notes on your own. So I want you to list all pairs of angles, practicing all of our definitions. When you're ready to go, answer the questions that are in Edpuzzle. So here's to see if you had the right answers. So the corresponding angles, remember the angles that are in corresponding spots or the same positions would be angle 8 and angle 4, because think of that, if you tilt your head, they'd both be in the upper left. Angle 7 and angle 3, because they'd both be in the upper right. Angle 5 and angle 1 would be in the bottom left, and angle 6 and angle 2 would be in the bottom right. The alternate interior would be in the inside portion, so you'd be looking at angles 3, 4, 5, and 6. But to be alternate interiors, they'd have to be on opposite sides. So that'd be angle 6 and angle 4 being a pair, and angle 5 and angle 3. Alternate exterior would be the angles that are on the outside. So I'd be looking at 8, 7, 1, and 2. The exterior, which on alternate sides of the transversal, would be angles 8 and 2, then angles 7 and 1. The consecutive interior or same side interior angles. So again, looking at the middle, so angles 3, 4, 5, and 6. So it would be angles 3 and 6, and then angles 4 and 5. And then consecutive exterior or same side exterior angles would be angles 1 and 8 because they're on the same side of the transversal, and angles 7 and 2. So again, a lot of our new definitions have a lot to do with if you know where you're at in terms of the transversal. Remember, our transversal is our line that cuts the other two lines in the same exact place in that corresponding location, and it cuts it into these 8 different angle locations. We can get a little bit more angle relationships out of those in the future, but for right now, we're just practicing a lot with those different relationships. The other thing that we learned in this lesson, besides those angle relationships, is the parallel postulate and the perpendicular postulate, which, remember, it says if you have a line and a point that's not on there, you have one line that's parallel to it and one line that's perpendicular to it. And then we just had some definitions of review with just what were parallel lines, skew lines, and parallel planes.